Great. So, yeah, today we're here to discuss the science of nutrition. And given our current testing ecosystem, as we focus on metabolomics, nutritional science is a natural haven for metabolomics. And metabolomics as a science really developed within nutritional biochemistry, and has been a mainstay approach in designing tailored, personalized nutritional protocols for individuals. And so metabolomics has enjoyed, a relatively successful research agenda within the confines of nutrition, and it is a natural extrapolation of metabolomic results. So today we're going to talk a little bit about nutrition. My co-founder, Dr. Mohr, is going to be heading the discussion. And that should be more enriching for you, since he is a PhD RD and has he's a registered dietitian as well, a nutritional expert. So we're going to be hearing from him on what Theriome is as a company, what the Aristotle test can do, what our processes are, and what we can glean from a person's nutritional index, and what kind of recommendations we give consequently. So without further ado, I'm going to turn it over to Alex, and he will take it from here.
Absolutely. Thank you, Dr. Jasby. Yes, I'm Dr. Mohr. I will say, and I'll preface at the very beginning, that while I am a nutrition scientist, it's actually one of my least favorite topics to talk about. And this is not because I'm not interested in the science. This is not because my initial attraction to it was based on biochemistry. It's that this is one of the most tribal topics that we talk about with our customers, that I talk about with my own family and friends. It's as triggersome as religion, politics. You really have to be careful. And we were very keen on making sure we describe this correctly in our title here. We're not saying nutrition science. We're saying the science of nutrition. Because if you look at what nutrition science is, or what it's really predicated on, when we look at how different policies are formed, how different dietary guidelines are created, a lot of this is based on, a lot of this is based on epidemiology, which is essentially tracking people observationally, right, in free living space, what they're normally doing over time. And from this data, we have to make sure that we're getting large data sets, or large a lot of participants, basically, because we're capturing patterns. Okay. And we're mainly looking, because we're assessing this over time, we're mainly looking at what we call odds ratios, relative risks, things of this nature, drawing associations. So when we go and inform, these guidelines, like I was saying prior, that's based off of population level metrics. It's not really based off of personal metrics. So we kind of flip this around with our title, The Science of Nutrition. We are very interested, and we have been doing now for quite some time, working on a personalized level, profiling your metabolism. And as Dr. Jasby was just mentioning, nutrition is fundamental to the type of signatures that we're actually going to detect when we profile your metabolism via our specialized test. And when you go to a doctor's office and you're getting your routine blood test, they're mainly benchmarking it against population norms. Again, going back to this population metric. So we are really taking a personalized approach, and that's what we're going to discuss today, and kind of help equip you with what our capabilities are and how you can actually take control over not only your health, but fundamental to that, your nutrition. So at Theriome, this is our company. Essentially, we're just kind of melding two terms together, the theory of omics. So, of course, a lot of people don't really know what omics is. It's just basically the end word, or the end part of the words metabolomics, genomics, basically all these different layers of what we define as systems biology, kind of thinking from the genome to the transcriptome to the proteome down to what we capture with this particular test, the metabolome, which is really an expression of your overall metabolism. Dr. Jasby, do you want to Dr. Jasby was really one of the main spearheading agents of this company, and I have to credit him with really kind of getting us to where we are now. Can you kind of give us a brief overview of how this all formed?
Yeah, well, as you know, this formed out of our collective angst during our doctoral training. So while we were graduate students, we noticed that there was a wealth of knowledge, meaning a wealth of experimental, observational, situational data that had been reported, peer-reviewed, and published that had lacked that translation to treatments. And we noticed there was this ocean of knowledge in the research space, whereas there's an odd trickle of that knowledge making it over from the bench to the bedside. And really, there is a lack of data quality in the sense that current diagnostic tools and techniques do not have the coverage needed to power the endeavor of personalized medicine or personalized nutrition, as we'll talk today. Keep in mind, nutrition is medicine. Nor was there sophisticated analytical methods for making sense of often very large data sets with high dimensionality. How do we take that then and analyze it to render a cogent meaning to our customers? And then finally, there was no method of taking those data points and those analytics and transferring them into actionable steps for a person to take that is, again, tailored to their results. And that is what personalized medicine or personalized nutrition really is about. And so there is no platform to do that. And as we begun our postdoctoral fellowships, and we realized that we could do something about this. We had the tools, we had the analytical platforms in our laboratory, such as next generation sequencing, such as advanced mass spectrometry. We had the bioinformatics pipelines developed that we use in our own studies, in our own publications and patents. And we had this new tool that has recently come into the health and science space known as digital twinning or in silico experimentation to predict how a person would respond to various interventions and tailor our approach to their health according to their results and their in silico responses to what we would simulate. And so we bundled this together as a package, and we thought that we could offer really what represents, the Aristotle test represents a vertical advancement in personalized care. And it's the first test of its kind that can monitor 126 aqueous metabolites that are sentinel metabolites that can report on almost 70% of all known human metabolism. Compare that with 10 to 20% if you were to stack other diagnostic tests. And then couple that with advanced analytics and a personalized approach to creating health protocols. And we could essentially give access, direct-to-consumer access to all of the research and institutional apparatus that we had helped construct in academia and make that available to consumers as well as physicians and doctors' offices. And that is what we're here to do. It says it right here on this slide. We're focused on leveraging the power of science to help our customers and our affiliates live a better life, a healthier, more fulfilling life.
I'm going to move this for you so that he can see you a little bit better here, because I can see Alex.
Okay.
Yeah.
So fundamental to that is actually making it very easy to get this type of testing done. We know that if you go to your yearly physical, or perhaps you're doing it every 6 months when you're going to see your physician, your primary care provider, you might get blood work. It might be a comprehensive metabolic panel. You might be getting blood chemistries, measuring, your lipids, kind of what's going on with limited minerals, maybe vitamins, probably not. What we're offering actually is a at-home collection method where we mail you everything that you need to conduct your own blood test. Very simple, non-invasive. Basically, it's a lancet. You're going to have a small blood collection that goes on a card. You're going to send it back to our lab, and very rapidly, we're going to process that with technology that is not used by the laboratories that your primary care provider is using. In fact, they're using quite antiquated methodology. We generally call it an ELISA, basically an enzyme-linked assay, which requires a lot of blood volume. I'm sure that when you get blood tests, how many vials are they needing to have just to profile a few dozen different biomarkers. With that small drop of blood that we're able to take at your home, at your convenience, we can profile that with advanced methodology like Dr. Jasby was talking about, and profile 126 different metabolites with extreme precision. Mass spectrometry has been around for quite a while, but it hasn't really been leveraged in the personalized medicine space. And, you know, a lot of that has to do with a lot of the bureaucratic red tape that surrounds its use. It is used in some limited circumstances. For instance, the Mayo Clinic actually has a core facility where they're able to do some of that profiling, but it's only very rarely used. This is not something that's readily accessible to most individuals. With the Aristotle, we bring that to your home. I mean, you can, like I said, order it, it comes to your door, boom, you're ready to go. You send it to our laboratory. We get great turnaround times. And not only are we able to profile these 126 different metabolites, we're actually able to essentially have coverage over, I think it's 84% of the metabolic pathways from these metabolites.
Yeah, it's 60, technically it's 68%. 68%. You put it backwards, but
Okay,
it's
sure,
fine.
sure.
Yeah, we're at 68% total metabolome coverage. So this is really important because when you go get your, you know, organic amino acids test, your CBC, liver functional liver tests, and then you stack maybe 2 or 3 other diagnostic panels on top of it, you're looking at roughly 10 to 20% of all human metabolism. So you're missing out on, you know, 40 something percent minimum if you got 20%, but on average, your even comprehensive metabolic panel, your CMP, it's laughable when they say it's comprehensive. They should really drop the C. And what we've developed is the most comprehensive metabolic assessment test currently available on the market, full stop. And then keep in mind that if you go and test your CMP, your CBC, your OAT, all of these other panels, are you analyzing them as one cohesive whole? No, they're all separate, right? So your doctor, if he has, you know, your heme levels, and that is one thing. And if he has your iron levels, that can actually inform your heme levels, and it'll tell him what is happening with your heme synthesis because it's contingent on iron, right? So that is a nascent model, a qualitative model, nonetheless, that the physician forms in their own mind, given their own training and expertise. No human brain can sit and model 126 parameters. And so what you're missing out on, even if you stack your other diagnostic tests and you try to increase the coverage of your own health surveillance and monitoring, you're missing out on that analysis that makes cogent sense of all of these otherwise disparate data points.
Yeah, absolutely. It's the human limitation. And when we describe the Aristotle to individuals, I don't think they quite get that. 126 metabolites, yeah, that's a lot more than you're getting with standardized testing. But
what's a standard test at 14 at the most for metabolic pathways?
It'll be anywhere from 2 to like 19 parameters, maybe. And the relevance of those are really kind of in question. Yeah. So we have these sentinel metabolites come from, and we've taken advantage of the redundancy in biology that's inherent in it. So when you go ahead and you take, you know, 126 metabolites, we've made sure that we can monitor each pathway that we're saying that we have good coverage in with 2 metabolites or more, because one metabolite will necessarily be present in multiple pathways often. And so we have 126 panels, right? If you look at how many models can be made with 126, how many associations, we can square that. That actually comes out to 15,876, right? Let's say your doctor working at full speed, right? Like full clip, is building one model in 5 minutes, which isn't going to happen, right? It's not going to happen that he's going to go through and build the statistical model and analyze in 5 minutes. But let's just say he is a supercomputer of a brain and he's doing each one in 5 minutes. So that's going to take him roughly 79,380 minutes, right? So we'll divide that by 60. And then we will times that by 24. So he will have to work roughly 31,000 hours to model that data. If he even had access, if your physician had access to 126 metabolites, you would have to work roughly 21 or 30. What was it? 31?
I think we multiplied instead of divided again, but the end result is
days. We did this on the back of a napkin at a business lunch earlier, and it was something like 4 years of like nonstop work if he doesn't eat, sleep, or drink.
Exactly. Assuming he's going to do work.
Yeah, assuming that that's the case. So there's no real tangible way that you can wrangle in data of this size without using the advanced machine learning tools we use, such as random forest or support vector machines.
Well, the practical application of that too is if a physician's no physician gets paid to do that. They get paid an hourly, every 15 minutes, that's how long you get to see a patient. You see him, you try to inform them the best you can in that short bit of time, and then they're on to the next one. So
Exactly.
There's no way, there's no test right now that gives them all the stuff that we're trying to offer.
Yeah, exactly. And so that's really the advancement of the Aristotle test and our processes.
Yeah, so this is just a truncated list. We're not obviously listing all 126 metabolites here. Some of these may be familiar to you. Some of these may not be familiar to you. But basically, this is the type of metabolites that we're looking at when we actually perform these types of tests. And this is what informs not only, obviously, these different pathways, but also we're looking at disease signatures. We're looking at risk for various different ailments, et cetera. And can go to the next slide. Forming these health indices, which again, kind of condensing information. The human brain can only handle so much. They're certainly not expecting you, if we profile your metabolome, to take those 126 metabolites and know what to do with them. We make it very easy for you. This representation here is just showing the 12 different health metrics or health domains that we profile and provide you basically where you're at, where you're measuring up to yourself, actually, and we'll explain that in a second. But this shows you where you need to focus, right? So in this particular instance, this individual has very low mitochondrial health, okay? So that's something that really needs to be addressed. And oftentimes we find that when a individual takes the recommendations that we provide from our enhanced algorithm and they apply this to a domain, other domains will increase at the same time. Right, because they're all linked.
Yeah,
they're all linked.
Yeah, these do not exist in silos. And so when you see something like mutational load, or you see something like liver, gut health, cardiovascular health, each one of these domains contains a subset of the larger 126 with different algorithmic weights and a bias score that's informed from a health survey that you submit when you return your sample. And so they're all linked. And by usually addressing one domain, we can address various factors of other domains subsequently. And our goal here is to sort of delineate them, but also keep in mind that they do not exist in silos, and everything is related and encapsulated in your physiological body necessarily. And so today we're going to be diving deep into the tribal nutritional index.
So the nutritional index is basically constructed from obviously many of the metabolites that we were just showing you, but we kind of focus and hone in on a number of them that we'll go over today. Obviously, when we talk about nutrition, we're talking about vitamins, we're talking about minerals, also some of the principal macronutrients. This is what really comprises the bulk of our diet. Think about your carbohydrates, proteins, fat. For some individuals, that may be ethanol in the form, right, of alcohol. We can detect things like that, right? And I mean, people do drink, and that can obviously have detrimental effects on their health, and we can capture that within our nutritional index and some other indexes such as the liver index.
So if someone lies on the thing and says, "Oh, I only take 2 drinks a week," you can go, "Oh, are you sure? Because this is high."
Or what we'll say is, well, you seem to be metabolizing slowly. You seem to have some sort of, most likely it's the conversion from ethanol to acetaldehyde is staying as acetaldehyde, which is a toxic byproduct. It's an anti-metabolite. Right. So when we see that, then we can say, well, your self-reported drinking isn't quite in line with what we're seeing metabolically. So if that's the case and you're going to continue drinking, there are certain things we can do to support your liver health, support the liver's ability to detox, such as recommending things like N-acetylcysteine or milk thistle. Both are indexed in our database of recommendations that are simulated on our customer's profile to match them with the best, not just treatment, but the dosage, frequency, and duration to comply with that protocol.
Gotcha.
Yeah. Other compounds as well, like caffeine, because we also see the same phenomenon. Some people are going to metabolize it much quicker. Some people are going to metabolize it much slower. You're going to have a different tolerance level. Like you, Matt, might be able to drink 9 cups of coffee. I can only have 2. I'm just simply not metabolizing it.
I should not.
Well, no. That's a problem you're going to have to deal with.
Yeah.
So, other compounds that we measure, for instance, here, ferulic acid, these are things that most people aren't really thinking about. You may have heard phytonutrients, phytochemicals, polyphenols. These aren't really captured a lot of times in different tests that you're getting, but they're actually very important for our health. And the case of what we're informing here for our nutritional index, this is kind of a marker, a polyphenolic marker of how many or what the quantity of fruit and vegetables in your diet is. It's actually has a lot of antioxidant properties that we know, particularly as we age, are going to be very important. And it's important to note that because there is a lot of different talks now about maybe limiting the amount of plant-based foods that you're getting in your diet. You know, there's not one perfect diet. And for any point in time, your diet may be different. Like unhealthy Alex's diet is going to be very much different than healthy Alex's diet, right? Yeah. Particularly when it comes to handling glucose, handling carbohydrate. And that's another metabolite that we actually look at, glucose-6-phosphatase, which is a key metabolite in carbohydrate metabolism. It kind of reflects how many carbohydrates you're taking in and how you're handling it, basically.
And roughly, when glucose is phosphorylated and is a phosphate group is attached to it, what it's actually doing is trapping that glucose inside the cell. Right. Okay. Glucose has to be phosphorylated or dephosphorylated for transport outside. So when we see levels of glucose-6-phosphate, we actually get a very good indication of your insulin resistance, of your insulin signaling, of what could things be going wrong. And it's not just with glucose-6-phosphate. G6P is a great marker for that. But and today we'll discuss like 6 or 7 of them. We do not have the time to dive deep into everything that is going into the calculation of a person's nutritional index, such as the amino acids. The amino acids are we'll talk about a few of them, like taurine, but the amino acids are incredibly sensitive and accurate reporters of a person's nutritional index, the absorption of those nutritions, the intracellular transport and kinetics of that micronutrient. We can ascertain using these key markers as they've been reported in the literature to have certain associations and node strengths with outcomes. So
I guess I have a question about G6, you call it G6P?
G6P, glucose-6-phosphate.
So I'll talk to people and they'll say, oh, I really don't have that many carbohydrates. I'm pretty good about it. I eat healthy. But so you're telling me that you can see an accurate depiction of what they're actually consuming.
Absolutely. So even if you don't eat carbohydrates, what if your body is making carbohydrates through the process of gluconeogenesis? That also informs us, because that glucose that is generated endogenously, once it goes into the cell, it's phosphorylated. It's trapped in there. And then to leave, right, you essentially need kinase enzymes come in and phosphorylate it. Phosphorylase enzymes come and dephosphorylate it. And so it needs to have that mechanism of action to go inside and outside of the cell. And so when we see that, when glucose is trapped, we get, okay, how much glucose is in here? And we get a sense of how that cell at a cellular level is regulating its glucose metabolism.
So it's obviously very helpful for people that they think they're eating healthy, but you're saying, well, I know you think you are, but hey, there's a problem over here. Like, so how early in the phase for diabetes could you say, hey, your insulin resistance is starting to creep up here? There's a problem here.
So one of the fundamental markers that they actually use to look at this is glycosylated hemoglobin, your A1C levels, basically, right? So we know that's basically the life cycle of a blood cell is about 90 days, So when we look at how glycosylated those cells are, we have to take that measurement every 3, maybe they'll even go out to 6 months. So there's a lag time, obviously. We're seeing an immediate marker right now that you could take, right, to see how your body's handling it. Because glucose itself isn't bad. It's how your body is managing it. Okay, so we have, obviously nearly unlimited ability to store lipids as adipose tissue, okay, proteins as muscle tissue. We don't do such a great job with carbohydrates, okay? So obviously, if you're a very active person, you can store carbohydrates in the form of glycogen, right? You're burning through that. Your liver has a limited capacity to store carbohydrates, and your blood only has about a teaspoon of sugar, the quantity of what we call glucose or dextrose, pardon me. So you have to make sure that you're maintaining that in a pretty tight balance. If you start seeing increases in G6P, that's an issue. You're not handling glucose very well. And that can set you up not just for diabetes, which is obviously, a huge concern, but one of the progenitors and so associated with cardiovascular disease, stroke, cancer is NAFLD, non-alcoholic fatty liver disease. So this affects about 25% of people that we know of. Okay, so this is basically your liver's inability to basically handle carbohydrates properly, and then lipids, and then you get spillover effects. It's a nasty place to be in, and this is a great marker to start assessing your risk to develop that.
obviously with nutritional index, you're gonna give them advice on what to do, but this is obviously, you see it early, you're like, okay, let's have a conversation.
Absolutely, absolutely. So taurine is another metabolite that we're looking at. So this is actually found obviously in protein-based foods, meat and fish. So we can get a good idea of how much protein you're taking in. You know, protein is pretty popular within the sports world, you know, exercise, but we find that a lot of people aren't actually eating enough adequate proteins, particularly the collecting the essential amino acids that we know are so important in maintaining healthy muscle mass.
Yeah, absolutely. And taurine is one of the most ubiquitously implied metabolites across our 12 key health domains. So we even talked about doing a webinar on taurine because it's so important, right? And its relevance to everything, it cannot be understated. And so when we see it in the nutritional index, we use it as a gauge of consumption of specific foods that we know are healthful.
Yeah, so this is all the background about when you're going and looking at nutritional index, these are big things you're looking at because they're indicators of whether or not you're eating a healthy, balanced diet that's good for your body. And different people's bodies require different diets to maintain a certain outcome.
Absolutely.
Yeah.
Absolutely. We don't wear the same clothes, do we?
Yeah.
We don't wear, we have different sizes of clothing, different fits and customizations.
Yeah.
How are we all supposed to have these nutritional guidelines that are meant to just be for the 95% of people? That's why they're so off. That's why we have a sick nation.
Yeah, it's interesting. So then like a dieting fad, you might have like 80% of the dieting fad done, but there's a little tweak that you need to do because it's not fitting exactly how your body's processing.
Yeah, and we'll get into these tweaks. Alex, you want to continue with the nucleotides?
Yeah, absolutely. So when we eat protein-rich foods, we're often thinking about the protein, obviously. We're not often thinking about other constituents, particularly in animal-based foods, animal flesh. One of those constituents, if we're eating cells, right, from an animal, we're also consuming their DNA, their RNA, these bases, adenine, guanosine, thymine, uracil. So this is really a reflection of how much animal products or animal proteins that you're taking in. Obviously, you can find these in some other materials, but this really gives us a good indication of, you know, if you are leaning towards like an animal-based diet, or perhaps you are trying to restrain from that, where you're coming in terms of that type of intake and how you're metabolizing it. So the other really important,
do higher or lower levels of these make something good or bad? Like like thiamine. So you're eating an animal-rich diet. Is there too much thiamine that you can get from eating just a
Sure, yeah, there can absolutely be too much, but you have to understand we're constantly having cell turnover. Okay, so we want to bring in not just the proteins to help, you know, build up these tissues and regenerate. We also want to bring in components of DNA and RNA because that's also important, right? Particularly the integrity of our DNA and RNA, which we know as we age, you know, those can decrease.
Especially as cellular repair mechanisms start to break down and we see the processes of cellular aging. This is something that we want to keep a close eye on. And so this is just as an example of how we can further refine our ability to assess how much protein is being taken in, not just from amino acids that are found as part of the constituents of proteins, because that's what they're made of, but the actual DNA and RNA constituents of that animal can have an effect, and they have an effect in the context of cellular aging. They have an effect in the context of cardiovascular health. They have an effect in the context of inflammation. And so, again, these are ubiquitously expressed across domains. And for the nutritional index, we use it as a gauge of their relative protein intake, protein turnover, nucleotide synthesis and utilization. These are all really important cellular processes that are absolutely overlooked because with traditional diagnostics, because they just don't have the ability to detect these analytes. Matt, maybe we should the microphone. You should scoot in a little bit more. I guess we're having a little bit of a difficult time hearing you.
No problem. Okay.
Yeah, I think one of the main things when we talk about protein. So for a long time in the nutrition world, it was thought that basically you want to try to limit this, you know, to around 15%. So that's most Americans are consuming a lot more of that relative to the total amount of energy that they're taking in. And, you know, we do know that in some circumstances, protein restriction can actually be very good for longevity. But as you age, your body actually becomes less sensitive to the effects of protein, particularly after the age of around 70. So we know that actually taking in more protein is going to be better in terms of quality of life, mortality. I mean, one of the most problematic things when people get older is the risk of falls.
Yeah.
We start talking about having lean muscle mass, not just as a glucose reservoir for
Right.
pulling in and managing diabetes, but just to keep you healthy in terms of movement, to keep your bones
Biomechanics,
full of minerals, et cetera. I mean, this is one of the most important things for older individuals is not just to worry about the risk of diabetes, but if they're getting in enough protein, particularly high quality protein, which we can detect with these types of nucleotides.
So there's always a lot of questions about plant-based proteins versus like pea proteins, stuff like that. Do you have like a weigh in on how that? You already smile.
Well, I mean,
he has a few opinions.
Okay.
yeah, I mean, so the main problem, and any rudimentary nutritionist, or I'm sure everyone on the call knows this, that you have essentially 20 different types of amino acids that we're consuming, on a day-to-day basis. Now you have essential amino acids, you have non-essential amino acids. Oftentimes, when you just get basic plant material in, you're not from any one food source, you're not going to get the full profile.
Mhm.
Okay. So that's why they have complementary proteins where you have to combine things. This is pretty well known. I mean, the classic ones would be like beans and rice, for instance. So beans complement rice in terms of the essential amino acids, so you get everything. Now, the problem comes down to the quantities. Okay. So most people, when they get caught up in thinking about nutrition, they focus on macronutrients, they focus on micronutrients, but they lose sight of the big elephant in the room, which no one likes to hear about this, but it's just how much energy are you taking in? Because it all has to come into the context of how much energy is coming into the system, how much energy is coming out of the system, right? So if you're in energy flux, that can be a problem, no matter how healthy, quote unquote, your diet could be. If you're in a hypercaloric state and you're putting on body fat, you're depositing fat in your liver, it's spilling over into your greater momentum, you're putting it in your visceral fat. That's unhealthy. Okay, bottom line, that's unhealthy. When you make these complementary proteins, oftentimes with vegan or even some vegetarian diets to an extent, you're going to have to usually eat a lot more. Okay, so for certain individuals, that are tackling obesity or having metabolic issues, maybe that's not the best approach. That's why I said, things can change depending on your health status, and your diet should change depending on your health status.
Right.
For someone that is younger and highly active, that might be a good paradigm to work with in terms of a vegetarian or perhaps even a vegan diet. The problem with that, not just from the protein standpoint, but the macronutrient standpoint, because you're not going to get in a lot of essential vitamins, okay, particularly vitamin B12. So you often know that you have to, I think
supplement.
Right. I think you dabbled with a vegan diet. You can feel great initially, right? Because if you're a really active guy, right, you're burning through a lot of the carbohydrate, it's no problem. You're in energy balance. You're getting good carbohydrate for your muscles to perform. But if you're not repleting with that micronutrient or you're not getting adequate protein, over time, you can actually start to see things like your performance might decrease, your muscle mass might decrease. And you're like, what the heck's going on? Like, I need to increase my calories or something, right, to fix this problem. And then that's where things can get a little problematic. But I will say, from experience and from working with people in clinical research, when we're conducting a diet study and people are coming to us and they are vegan or vegetarian, oftentimes their diet quality is not very good.
Right.
Okay.
They're just not eating enough.
Well, not eating the right things.
They're primarily focused on starch. Okay. Because, we're not going to get into a lot of this in this particular talk, but there are a lot of mental behavioral cues that go into diet. We all know the food is very rewarding, right? Yeah. Very rewarding. When you feel like crap, right? And you're stuck in a certain dogma, because a lot of nutrition can be dogma, and it happens on the other side too. Yeah. Don't think that it doesn't. Yeah. But
eating carnivore versus
right.
And
I'm not saying that doesn't have credence or that doesn't have a time and a place.
Sure.
But I'm saying if you get so dogmatic and you start setting up barriers, well, I can't eat this because I believe in this. And you feel like total crap, all the time, what are you going to do?
Yeah.
Okay. So you're going to seek out certain types of foods. And that's just not good for anyone's health. Right. So we are not wedded to any one particular diet. We're wedded to a diet that is most in line with your current physiology now. And as you adopt our recommendations, that may change. I'm not saying that we might go from a vegan to a carnivore diet, but we're operating on a spectrum.
Right. Yeah.
Yeah, and we tried, and with our digital twinning recommendations, it is very advanced and nuanced. And so if we recommend something like omega-3 supplements from fish oil, but the person has indicated that they observe a vegan diet, we will then switch to like algal oil, right? The algorithm will instead give the recommendation of algal oil, which is in line with their, we give alternatives.
Right.
Obviously, we're not here to change someone's belief on how they should, I mean, that's their choices. All we can do is in line with their beliefs and their chosen diet that they want to observe, we can bring them the recommendations, and we'll discuss how we do that and exactly what we can offer. But we can give them very tailored recommendations to address their nutritional deficiencies, address their diet, and maybe even modify how they eat, which is, you know, we are
a nice little bipartisan nutritional recommendation.
And we don't sell anything either, right? Like we're not making money off of these supplements. We don't make you know, we're completely detached from them. It is really just a stoic observation of what's going on, and a very clever and custom made recommendation based on a metabolic profile. And so obviously we have, you know, niacinamide and pyridoxine, important B3 and B6. We won't spend too much time on this. I think a lot of people have colloquial knowledge on this. And, you know, in addition to this, we have other B vitamins. We have the effects of those B vitamins. So not just looking at cobalamin, like methylcobalamin, but looking at what that works on: homocysteine, methionine, cystathionine. All of the interconversions. It's not just these metabolites on the screen that we're looking at, but keep in mind that we have mapped them to the human metabolome in such a way that we also get a very accurate sense of the peripheral function in that metabolic circuitry. It's not just how much it's there, but what's it doing?
Give me an analogy for that. Like, so you're saying that being able to look at one or two metabolites, the way that they affect other nutrients, metabolites in their body. Give me an example of like, how could you explain some of that didn't go through biochemistry and understand the Krebs cycle?
Okay, so vitamin B3, for instance, I mean, this is something that we should all be getting in our diet. You actually really don't need that much. Milligram amounts of the equivalent. I think it's 4 to 12 milligrams per day. But basically, this is a precursor to NAD plus. Okay, right? Everyone's heard of that.
Loves it.
Everyone's getting infusions.
Yeah.
I'm feeling you're getting infusions. I'm not getting infusions.
Yeah.
My wife's getting infusion. Yeah.
Right. But you know, what are these actually doing?
Right.
Why is this actually important for health? I mean, particularly for anti-aging.
Right.
Do you know?
No, I would love to know.
Okay, so there's actually a class of chemicals that we call sirtuins. Okay, so as we know, we just talked about replication with DNA, dividing cells. We want to keep our cell integrity, the DNA, the nucleus, as intact as possible as we replicate, as we grow tissue, as we age. That's very important. Sirtuins basically are stewards of that process. Okay. So having robust levels of niacinamide, making sure you're replete, is going to basically offer up, you know, a better route for these sirtuins to operate and ultimately help you age better. Okay. So we're talking about vitamin B3, just little old vitamin B3. If you're not getting in enough, you're not going to actually be activating those types of processes.
Specifically known as redox reactions.
Yeah, so
They're electron donors and acceptors. That's really what
you speed up aging. Yeah, basically.
Yeah, you speed up aging. Yeah, exactly. And so, you know, with B3, B6, B12, we're not just looking at these metabolites, but also the processes that they affect. We were looking at the downstream processes that they're implicated in.
Are there specific foods that niacinamide, it would remove that as a molecule in your system because you're eating this other food?
Like a glycoside type of situation?
Yeah,
Sure. Certain conjugates of niacinamide in supplemental form are poorly absorbed, for instance. They have differential absorption. So we're very, you know, we usually recommend a riboside version of this supplement. And our test can actually tell you, listen, you need sarcosine. And we're going to ask you to get it either in a supplement form or from your diet, these specific foods and these specific gram amounts and these specific, you know, daily increments. Why do we make that distinction? Because given your certain metabolic profile, you will have variable absorption and cellular transport rates such that for just one compound like sarcosine, one person may benefit more from getting it via supplementation. The other person may benefit more from getting it via the diet. And so our test can even tell that apart.
Interesting.
Yeah. The fatty acids, these ones are fun.
Okay, so yeah, oleic acid, this is a monounsaturated fat. You know, seed oils definitely don't get a lot of love these days.
No.
You know, a lot of it is for good reason, but again, a lot of this comes back to what we're pulling out from patterns from epidemiology, these large observational studies. Now, I think in general in the United States, people are over consuming seed oils. Absolutely over consuming seed oils. But you also have to look at oftentimes what those are packaged in. For instance, baked goods, notorious for having a high load of seed oils, processed foods, packaged goods. So if you're consuming a lot of those types of foods, you're going to get in a lot of seed oils. Now, oleic acid is actually a very important monounsaturated fats that's found in what we would deem as healthier oils. Again, within the context of how much energy is coming into the system, okay? So these are found in things like olive oil, avocado, some nuts. So it is important to actually get this in terms of your overall health. And we're talking about the health of your cell membranes, packaging up
central nervous myelination.
Yeah.
I mean, these are the compounds that then go to myelinating axon sheaths, to myelinating entire nerve bundles. And so when we see a depletion in this, in fact, if you take, newborns, and this is, 1950s science, and you put them on a low fat diet that's low in oleic and linoleic acid, you will see cognitive and mental disturbances even as early as 1 year of age. So if you just take the newborns and you put them on a lower or fat reduced diet, and we've seen it in animals, we've seen it in human trials, this is the result. And so it's very important for the transmission of nervous signal and the fast conductance of those electronic transmissions in the central nervous system, the peripheries. So it is incredibly important and sometimes overly maligned.
Sure, yeah.
But
because I hear nothing but seed oils are bad, stay away from them.
Well, you don't have to just get them from seed oils. You can get them from, avocados, olive oils. They're in other things too. And so making sure that you have enough to facilitate those really paramount cellular processes, where if you leave it unchecked, you can develop, for instance, permanent neuropathy. Then there's no treatment to go back on that. You can develop permanent scarring in your myelination, your axonal sheaths. And so those sorts of outcomes we want to catch early and address immediately.
So I think one of the most fundamental aspects of our test and what we're actually able to provide and how granular we can actually get with our recommendations comes down to our IP surrounding what we call digital twins. So when we look at these health scores, for instance, and we look at forming these recommendations, it's not what you get with your general practitioner when you look at blood tests, comparing you to a population arm. We're comparing you to yourself, okay? And really, I mean, what does it matter if I'm comparing my cholesterol levels to Matt's or, my vitamin levels to Panini's? It doesn't really matter because our physiologies are different, right? So when we take all these metabolites and we form out these different health indices, we know to make sure that we're giving the most refined recommendations specific to you, it has to be in comparison to yourself. And that's exactly what we do with this model for all of the health metrics that we have. Basically, detecting what is going to work best for your metabolism, what type of diet is going to be most in line with your current health state, what you need to take in terms of supplementation, what's going to be most effective, how that should be taken, even down to should you be considering different nutrient timing aspects, should you be fasting? All these things are very important that when you read books or when you listen to podcasts, you're hearing population level statistics, right? And recommendations. That is not appropriate for you. And that's where it comes down to, like, what's the best diet for you? Well, it's whatever works best with your current metabolism, right?
Absolutely. And so this is a technique that was really developed in the aeronautical and aerospace industries, where instead of fabricating, let's say a rocket ship, a spaceship, and then testing it with liftoff and reentry and all the things that it would experience necessarily on its trip to the Mars or Moon or wherever it's going, it's very time consuming because you have to keep iterating and manufacturing and iterations. Whereas if you create a digital replica of that in silico and experiment with those physical forces in silico, re-engineer in silico, iterate in silico, you only have to fabricate that part once. And so you can imagine the time and cost savings of this. And this is really where it was developed. It was developed as a tool for NASA to sort of cut down on the time and the cost of producing these very specialized craft. And in the last maybe 5 years, it has had an appreciable interest expressed from the health and science communities. Can we take that same thing? Can I take Matt's metabolic profile, deconstruct you to a sort of network node module, and then simulate the effects of various interventions, be it intermittent fasting, specific changes to your diet, specific supplements you may take, and then do so with varying dosages, times of day to take them, and then simulate the response and see what did your metabolic profile respond best to, and then curate that in a protocol and leverage all of those thousands of interventions, thousands of iterations that we've done. Each intervention is iterated 1,000 times. And we leverage that experimentation so that you don't have to experiment on the real.
Yeah, I love that. I love the idea of not having to try something, wait a week, wait 2 weeks, wait a month. Like I buy everything, I get in this idea, I try to get into a habit, and then a month later I do a blood test and realize that's not helping me.
Exactly.
Yeah.
Or even hurting you.
Yeah.
At best, it may be ineffectual. At worst, it could be harmful. And so we've done that. And so this is for one person, one individual who is now one of our physician affiliates. This was the test he did on himself.
Gotcha.
He's a functional doc, an MD, and we have a great relationship with him. And we tested his whole family. And this was just his recommendations for the nutritional index alone. One thing that we recommended was a initial 2-week fast. We wanted him to fast for 12 hours a day from 7 p.m. to 7 a.m. Alex, do you want to talk a little bit about intermittent fasting, especially the research that we have done already published and what we have in the works that's at Nature Communications?
Yeah, absolutely. I mean, intermittent fasting, if we think about how humans have kind of...
Can I stop at that? So you guys actually are publishing an article about fasting specifically.
Multiple articles.
Alex is a thought leader in this specific area, to be honest.
Yeah, multiple papers. It's something we're very fascinated about because, again, going back to where our minds kind of fixate in terms of nutrition, as I was saying before, it's on the macronutrients, it's on the vitamins. Very rarely do we understand the umbrella of, the energy state we're in, but also the timing of when we're feeding, when we're not feeding. If you look at how we've evolved over time, it's been very rare that we've had basically spending all waking hours in what we call a postprandial state, basically digesting food.
Right.
Okay. Now I know you don't do this, of course. You haven't even.
Why not? I hope not.
But up till very recently, it was very common to basically have the 3 squares, what we call, right, and then snacks intermittently. You wake up. You get your breakfast. Yeah. You're already handling glucose. You're handling fat. Your body is starting to process that. Okay, that takes hours. Okay, and before that process is even finished, you're on to lunch, or perhaps you had a mid-morning snack. Okay, your body is in constant digestion mode. Okay, and because of that, you're constantly having various nutrients in circulation. There's nothing wrong with that. But it's how often that's in contact with various tissues and how that's fluxing over time, particularly when we talk about something like glucose we were just discussing previously. If we have constant elevations of glucose and these dips, right, that can be really problematic because now not only do we have to make sure that we're tied to a food source constantly, but now we're getting this exposure and we can have things like glycosylation happening, which not is only problematic for the blood cells, but also in terms of
that? Can you tell me that? I don't know.
Basically, it's when sugar residues attach onto things. They're very sticky in terms of the molecular chemistry behind them. So they stick onto things, okay? When they start sticking on...
What's it called again? It's called
glycosylation.
Glucose, it's kind of like, a lot of chemistry kind of plays on words. So once you get some root words down, you can kind of figure things out, right? Yeah. So, I mean, the problem with these is they can actually act as what we call basically for like a ligand or something that's attracting something. Okay, so things can get attracted and they stick on. Okay, proteins can stick on them. This becomes really problematic, particularly when we talk about our circulation. Okay, we know, we often talk about heart attack and stroke and things like that. This is all diseases of the circulation system. And I hate to keep talking about like the liver and cardiovascular, but this is all really interrelated and tied.
Everything, exactly. We can analyze it discreetly, but it's really so integral to all the other health domains that we monitor.
So we see the rise in all these chronic disease kind of mirror our dietary practices, right? Yeah. Now we're not, most of us are not really that physically active, meaning that I'm not working, shoveling for 8 hours a day. I'm sedentary most of the time. I, might be able to get an hour workout in or something, but that's not really enough to combat this constant influx of nutrients. Okay. That's not really how our physiology is in tune.
From an evolutionary perspective.
But also if you think about even the circadian rhythm, there's clocks, we call clock genes in every single cell in our body that is in tune with the night and the day cycle. Even the microbes in our gut have their own circadian rhythm. So, I mean, this is something that's fundamental to our physiology. being in a constantly fed state for most people, unless you're extremely physically active, is going to lead to potentially some very serious chronic diseases like NAFLD, like stroke, like cardiovascular disease. I mean, cancer is a completely
Alzheimer's even.
Yeah,
Alzheimer's has a very direct link to this constant cyclical cycle of postprandial glucose spikes that Alex was referring to.
And it's not only just eating too much at one time, it's eating too frequently. So
yeah.
it's almost the same amount of calories in this. You could eat the same thing, but if you ate it too consistently throughout the day, that's worse than having it all in one sitting.
Yeah, absolutely. So in our research, what we actually looked at this 8-week trial, because by the way, in clinical research like this, it's very hard to get people to adhere to these things,
I'm sure.
which is a nightmare. We don't have that discussion, but basically, for 8 weeks, these individuals, they were in a randomized controlled trial. We had an arm of that study follow an intermittent fasting diet where they fasted 2 days per week, complete fast. Okay. Now, for most people hearing this, that's a long time, right?
But so with 12 hours is long.
Well, this is specific to the study. This is a different case study. Right?
This is what we recommended based, like the dosage of the intermittent fasting was based on his needs.
Right.
We could have gone higher or lower. And in fact, we've tailored it here so that he would actually ramp it up.
But what was the
after 2 weeks?
fasting
This was for the study.
So the fasting duration was basically, it's not 24 hours because these individuals were fasting. You think about the time that they stopped. So 36-hour time block. So a total of 72 hours.
Yeah.
Okay.
Right.
So that's for most people, that's pretty
long.
But these individuals were also obese. Okay.
Yeah,
so they had some storage capacity of their own. So one arm followed that diet. They were matched for obviously their body weight, their sex, all the BMI, et cetera. And then our other arm followed a diet matched for calories, okay, and macronutrients. So they're eating the exact same thing. They just had no fasting, okay, and they could basically eat in their waking hours as they whenever they wanted. But we did supply them meals, so they were technically eating a normal 3-day meal setup, right? So they followed these two diets over a 8-week period. Both, by the way, were calorie restricted by 40%. So this was a calorie restricted diet. Those that were following the intermittent fasting lost significantly more, double the amount of body weight. And we actually did DEXA scans, and it was all coming from their adipose tissue. There was a little bit of non-significant loss in protein, which occurs, and that's just not from muscle tissue. If you're a large person, you're losing weight, you're actually going to be losing things like skin and different connective tissues. But the loss in visceral fat was absolutely phenomenal.
Visceral fat. This is fat surrounding your viscera. This is the bad fat of the gut.
Yeah, this is the stuff that
abdominal fat.
Because if you think about where your liver is in proximity to your viscera, right? Your guts, basically, it's very close. And when we are metabolizing food, particularly carbohydrates, and we're packaging up fats, they're coming out of that portal vein and they're going right into that area. And when you overload the liver, when you get something like NAFLD, that fat is depositing right in the viscera. And that's why we get this epidemic of visceral fat. But basically with fasting, we're able to basically this is very simplistic, but basically let the body rest, let the liver rest, okay, and clean up and activate what we know now is very important in terms of recycling different tissues, different cells, autophagy. Okay, basically making sure everything has time to rest and repair and basically recycle damaged components of things like mitochondria, which we know are very important for energy turnover, basically just giving the system a rest. And I know it's very simplistic, but that's how most people can kind of understand and conceptualize it.
That makes sense to me.
Yeah, I mean, you think about, we have this immune system that is designed to prevent things from the outside affecting your inside, right? That's a very easy to understand conceptualization overview of the immune system. We have this process in our body, and yet every day we consume things from the outside. You take the external world, you internalize it, and we've forgotten that this is always a homeostatic challenge. And it's not one that is in line with our evolutionary abilities.
Yeah, unfortunately, my availability to food is significant. Uber Eats and
we used to chase the food supply. Now the food supply chases us. There's advertisements for food, right? The food supply is chasing us. And because of that, we've forgotten that, this isn't really how people would eat. And so for this gentleman, for this physician, he was already observing an intermittent fasting protocol. We asked him to just increase it by 1 hour on each end and then intensify it. So he had a 12-hour daily fast. During that time, we recommended he consume water, herbal teas, black coffee, and then breaking the fast with a meal balanced consistently of 30 grams protein, healthy fats, high fiber vegetables. And then after 2 weeks, we asked him to increase that protocol to 14 hours a day, and then gradually introduce small amounts of lean protein for breakfast. So that's where he would be essentially breaking his fast at 9 a.m. with that meal. And then subsequent weeks, we increase it to 16 hours. So 7 p.m. to 11 a.m., no food. And then we kept monitoring energy levels, caloric intake, and he was a physician.
Do people find it difficult when you make the recommendation to fast for that long?
No, I used to do 24-hour fasts.
Yeah, but so an average person, when they look at that 7 p.m., like I can't eat past 7 p.m. and waking up at 11. No, I wake up, start my day, and pretty much just wait till lunch to eat.
Yeah.
Are people pretty accepting of like that's an acceptable window of eating?
It absolutely is. It's safe, it's effective, and it is, again, tailored to this individual's biochemistry and what we've seen.
And their metadata. So
Yeah.
when someone is getting our test, they're basically taking a survey for us. Okay. So we get an understanding of what they're doing currently. Okay. So we're never going to say, okay, Matt, you eat, 9 or you eat 3 times a day. You're basically in a fed state all day. I want you to do, Ramadan, right?
Yeah.
Yeah.
Yeah. So that's not happening, right? We're going to do things in a stepwise fashion based on what you are doing currently coming in.
And the hope is that I feel better on the first little step, and I'll take the next one. I'll take the next
Right. So we always gradually ramp that up. So he has a 2-week ramp, and then after those 2 weeks, subsequent weeks, he can ramp up according to his own desire. And so this physician was already doing intermittent fasting. And intermittent fasting is very popular among researchers and physicians because we know the effects of it are really beneficial. So this was one way where we're not telling him how to modulate his diet or supplements. We're just asking him to eat how he eats to change that, essentially. The method of
you want the same diet, keep the same, just don't eat between these hours.
Right. And we didn't actually just stop there because we asked him to change his diet. So we asked him to include spermidine rich foods. Spermidine is one of the metabolites we monitor in the nutritional index that gives us a sense of the data of the diet quality. Also, it's a great marker for cellular aging. So for this physician, we recommended 30 grams of wheat germ per day. We also asked him to integrate 200 grams of mushrooms at least 3 times per week, and then include 100 grams of soy.
What do you get out of mushrooms?
Spermidine. So, spermidine is actually very interesting. We most find it in aged foods.
Yeah.
Which is funny because it's actually very good at helping provide some
anti-aging. Yeah, exactly.
Gotcha. Okay.
Yeah. And so we asked him to increase all of these foods and these very specific things. And because we also did an analysis of what foods would be best for him and also in line with his self-reported diet and what he's observing. We wanted him to increase his fatty acid intake. He was a little bit low. So we asked him to increase to 150 grams of fatty fish, salmon or mackerel twice a week, 2 tablespoons of flax seeds daily, preferably ground. So this is the granularity with which we can give a health protocol. It's not like going to your doctor and he says, well, you need to eat better, stop drinking and quit smoking. These are very detailed and respective of a person's routines and diet.
So every person that would get a test would get a different.
Yeah, this is just for one person who scored a 4 out of 10 on that domain. So he was in the normative range, but obviously lots of room for improvement. Mitigate palmitic acid intake. So I love to have a great steak before I go to bed. Matt, you and I were just talking about that. But too much is bad. It can actually cause an immune response. It can increase the propagation of inflammatory cascades downstream. Palmitic acid is recognized by immune cells as a pro-inflammatory molecule. So you want to have some of it because it's essential for other processes we discussed, but not too much. So we asked him to limit his red meat intake to 100 grams once a week, and then choose a low-fat or non-fat dairy option. Now, so that's how we approach this problem with 2 ways. Then we get into the supplementation that we recommended for his nutritional index. Niacinamide, he was low on. So initiate with a dosage of 250 milligrams once per day. If well tolerated, no side effects, incrementally increase by 250 milligrams every week to no more than 1,000 milligrams a day, divided into 2 doses. So we can tease apart when to take it, how often to take it, when to ramp up. We will ask him to regularly monitor these adverse reactions that are typically known to be associated with the upper tolerable limit of niacin. But of course, he's a physician, so he has his fingers on the pulse, so to speak. And then sarcosine, we wanted him to start with 500 milligrams per day. After 2 weeks, if well tolerated.
Sarcosine. This is the first one we talked about sarcosine.
Sarcosine is another anti-inflammatory, anti-aging metabolite that is also highly correlated with good diet quality. So people who are having a very balanced omnivorous diet with high quality sources of foods, whole foods, non-processed foods, will have good adequate levels of sarcosine.
We also see this actually with people that intermittent fast. We actually
Yeah.
see levels of sarcosine going up
Just because of fasting.
Yes,
just because of fasting.
absolutely. Yeah. And so the first study we published, where's it published in? I forgot.
Scientific report.
Scientific Reports is the first intermittent fasting protocol we published. This next one is a Nature Communications that is a very advanced journal. A lower acceptance rate than Harvard University is what we always say. And so it's a very prestigious top 1% of journals worldwide. That's currently in review. We're optimistic it'll get accepted. And we monitored the metabolomic response to this. We monitored the microbiome response to this. We integrated levels of these different omics fields to come up with very insightful data and results. And that's why we're at consideration as these great journals. So sarcosine, we asked him to do the same thing. We told him how much to take, how much to ramp up to, and when to take it. And then finally, we wanted to hit him with some antioxidants that we saw were low and would also increase the absorption, intracellular transport, and utility of these nutrients that we're asking him to modify via the diet, the supplements, and the intermittent fasting. Vitamin E, starting at 200 international units a day, increasing to 400, and remaining watchful for signs of excess. Vitamin C, a potent antioxidant, although with a notoriously low half-life. So we want to give him 250 milligrams a day, up it to 500 milligrams a day, 2 doses, watch for excess signs. Same thing with CoQ10, which is a ubiquinol.
I don't know what that is.
CoQ10 is a cofactor for the various biological processes that we have in the body. So everything from oxidative phosphorylation, which produces...
What does it do in your body?
It is really important for mitochondrial function. So when you talk about energy production, CoQ10 is an essential cofactor, and one that when you look at the population level data, the epidemiological data, the populations are chronically low.
Also, if you're taking statins, it can deplete the
Yes.
levels of CoQ10. And
So
most
why does
people,
the statin deplete CoQ10?
it has to do with your liver metabolism. So it makes your liver less efficient actually getting this to where it needs to go and having the metabolism of it operate at where it needs to be operating at.
So is it common practice for a physician that has a patient on a statin drug?
It should be. From what I hear, this is actually there's a better understanding of taking this in conjunction with statins, but for a long time, this wasn't understood.
Yeah. And so you see things like malaise, fatigue, mild cognitive impairment associated with statin use. And it's because of CoQ10 and various other things, because statins have very diffuse effects. It's not just one thing.
Yeah. It's affecting the whole body.
Yeah. So with our tests, we have different levels that you can go in on. If you just want the health score report, that would be essentially a 12 key health signatures. Basically, what you saw earlier. Where do you stand? It is a broad survey of your metabolism. We monitor 126 metabolites, and we report on your standing in these 12 health domains. If you want the personalized protocol, that's an additional 199 or 199, by itself. And so what we would do is we take the 126 metabolites, we tell you where you're at, and then we answer the question of now what?
Yeah, now what?
So you would get a protocol like that, but keep in mind, this protocol that we reviewed is just for the nutritional index.
Right.
For every one of the other 11 health indices, you'll receive a bespoke protocol that is fit to your metabolomic profile. And again, we have no interest on selling products, selling therapies. We don't partner with anyone. So it is a very the integrity of our recommendations are not compromised. Good. And then we have a disease signature report, which we haven't even discussed because it's its own discussion. We have 344 disease signatures that have been validated in human blood. And what we essentially do is we take your metabolomic profile, you can think of it as a network, and we corroborate, we match against those 344 disease signatures, and we present necessarily the overlap. How similar is your metabolomic profile to breast cancer, to schizophrenia, to autism, to histidinemia, and various other even metabolic disorders, Alzheimer's disease, cardiovascular disease, early markers of myocardial injury, various seizure disorders. And we present a risk for that based on your metabolic profile. I was recently discussing with our CEO the science of an article I was reading on a plane ride to a conference. They took 2 groups of people. One was obese and one was metabolically obese. So whereas they were normal weight individuals, 18 to 25 BMI, their metabolic signature was in line with obesity. So when we look at the metabolic signature of obesity, there's a few biomarkers we can pick out, and essentially it accurately predicts obesity with 90% accuracy without even knowing the weight or height of an individual. So they had the metabolic signature of obesity, and this was in 7,600 participants undergoing a prospective cohort trial in Europe. And what they found when you look at the truly obese people with the phenotype of obesity versus the normal weight individuals that had the metabolic fingerprint of obesity, you follow those 7,600 individuals for 19 years, you have the exact same or roughly the same incidence of type 2 diabetes and all-cause mortality. So
it doesn't matter whether
it doesn't matter if you're obese or not. The metabolic signature of obesity is itself its own thing that can be tracked and monitored. And so when we look at these issues, oftentimes it provides a sort of roadmap, a quick roadmap for the most usual suspects that physicians or even our consumers can use to say, okay, I have something wrong with me. Could it be these that I have a significantly increased risk for? Yeah. And that's what we report in the disease signature report. You can also get the full report, which has essentially everything that's analytical about us. We get 126 metabolites, 12 key health domains, the disease signature report, as well as the digital twinning protocols that we've seen for each one of our 12 health domains. And then you can get the full report and a consult. And so you will meet with a member of our science team. That member will always have a PhD. They will be trained in systems biology per se, and they will be able to provide you an enhanced protocol, identify areas that require immediate addressing, as well as answer your questions. And we've seen that is really helpful and impactful to make our customers feel empowered and give them, really the tools they need, the interpersonal tools they need to comply with that protocol and really achieve that promise of improved health engineering that our digital twinning platform provides.
You'd have to listen to you for I think we were on for an hour so far. You cover a lot and you know it so well. From my perspective, I don't want to have to learn everything, but I want to know, hey, point me in the right direction here.
Right.
And I'll make an adjustment. And then if I'm still missing some things, I think that's where the frequency of testing is obviously
right. And our report is fairly easy to digest, and that digital twinning protocol is written in the same language you saw on the screen. Yeah. It's very easy. However, still, we like to provide that human touch. Yeah, not everything can be AI and machine learning. There is some level of expert human knowledge that has to be interwoven. So that's what you get with the full report and consult. It's a 30-minute consult. So compare that with what you got at your last physician's office. And then finally, that's our sort of presentation on nutritional sciences. This laboratory you see behind us is Wexford Science and Technology. Our laboratory is contained on the third floor of this beautiful billion-dollar facility. And we are currently running our Black Friday deals. They start today. It's the best offer of the year. It's 25% all of our products. It is limited to the first 100 orders, actually a little bit less than 100 since we sold a few this morning. It will be available until November 27th. So keep in mind, you have various options, what you want to buy, depending on what you need. What information do you want returned to you? How much do you want us to be a part of your health journey? And everything is 25% off. If you have any questions, please email us at info@therio.me. You can visit our website at therio.me and learn more about our science, our team, our products, and what we do as a company.
Yeah, I think, I don't know if Mike is going to take it. There's a bunch of questions in the chat or questions. Do you want to go through that, Mike, or do you want me to take care of it?
Yeah, we got a number of questions here. So let's take a look at the first one. So a question from Becky was, will it show if you're not absorbing the nutrients from protein?
Absolutely. So when we talked about, adenosine or adenine, guanosine, thymine, uracil, when we talked about the various amino acids that, although not displayed in our presentation, that we do monitor and include part of the calculation of the nutritional index, we can tell you what proteins are being absorbed, what kinds of proteins from, different differential absorption rates of, animal protein and plant protein. Some people absorb them at different rates. Well, most people actually absorb them at different rates. We can tell you where that process is going wrong, and I recommend.
What would be the reason why one person would absorb the protein differently than next?
Yeah. So there's various clinical reasons. Do you want to take a stab at it?
Sure. Well, so my background is actually in, you can think of it as gastroenterology, particularly with the microbiome. We know that, when you're consuming foods, a lot of the digestion of proteins actually starts occurring in the stomach. Okay. So a lot of this actually comes, like, if you think about the alimentary canal, basically from your mouth down to, the back end, that's not, it's inside your body, but it's still considered external, external environment, right? So a lot of that digestion process is actually occurring in the alimentary canal. If you don't have robust digestion, whether you're not producing adequate precursors to the hydrochloric acid that is in your stomach, the various
protein chaperones that are expressed,
right.
Enzymes that are secreted from the pancreas.
From the pancreas, exactly. A lot of people actually, the pancreatic health and liver health, particularly if you're not particularly when it comes to digesting fats and things like that, with bile, like your digestion plays such a huge role in how you're going to digest, like pull, not just break down the food, but then pull the nutrients from the food. It's actually quite complex. And particularly with that interaction with the microbes that we know that are also at play. So if you don't have a robust microflora, the microorganisms that are inhabiting that area, you're not getting in the proper nutrients in terms of the precursors that are producing a lot of those enzymes and bile and things like that. You're not going to be digesting. I mean, you can have the best proteins coming in. You're just not going to be digesting it very well, particularly when you start talking about someone like we're going back to the vegan discussion, right? So not only can, as Dr. Jasby was saying, detect, what you're absorbing, we can detect what you would best absorb if you had to make that adjustment.
Right. Absolutely. Gotcha. Yeah. You have another question for us, Micah?
Yeah, another question here is, does it measure ammonia and ammonium?
Yeah, so we have many metabolites of the urea cycle, such as citrulline or ornithine, that can tell us about your ammonia turnover and the processing of ammonia and conversion of urea. So yes, we do have that, and it is something that oftentimes we see is a downregulated process in a lot of individuals. Either they're consuming a sort of a high protein diet, or they have poor protein turnover. That is something that we've identified before, and definitely will address if it's something that we see in the test, if it's there, right? A lot of people, I think, approach our test with like preconceptions of what's going on. And when they take the test and we give them, sort of point them in another direction, they sort of think, well, I thought it was my protein turnover.
Right.
And we do see that. We did consult recently with an individual who had proteinuria, high protein levels that was resulting in a foamy urine. And so that has to do with the ammonia content and the conversions to urea and back and forth. And so we definitely can identify that. And if it's an issue, we have many interventions to address it.
Another question here is, this must be a physician. Do you have case studies showing it being used in practice?
Yes, absolutely. And we have a few that are related to nutrition. You can go to our website and download Metabolomics Handbook that we've written. And that handbook is set in different sections. So if that question is being asked by a physician, they can skip to, how to implement this in your clinic. And then in that section, there are, I believe we've given 4 case studies, various things relating from, autoimmune disorders to protein enzyme disorders. And our case studies have always been the best ones that we've had, have always had some sort of physician involvement. And really, I think in the hands of the physicians, our test really does shine. And so you can go to our website and download the book, and you will see in the case study section of it, it's a rather kind of a long read, but there you can just jump to that in the table of contents and review the, I believe, 4 case studies that we've included in there, and they're sort of benchmarked to traditional clinical parameters.
Great. A couple more questions here. Also, would you mind taking the screen share off so we can see you guys better?
Yeah.
Yeah, this person also, well, their follow-up question is, are there texts and sources for practitioners to learn more about the metabolic profile and how to implement into their practice? So as Dr. Jasby said, if you go to the website, which is therio.me, I'll put it into the chat here. Right on the front page there, it's gonna have a button that you can click to download Dr. Jasby's book. So if you just go there, put in your email, it'll send you Dr. Jasby's book that he's done a pretty comprehensive overview, not only of this test, but just testing in general and metabolism. So he goes through that very, very well. Another question is, here, do you identify glyphosate levels or anything that draws the connection between the sarcosine, et cetera, and the impact of the poisons in the food supply as they are impacting?
Yeah, absolutely. Gosh, so my postdoctoral mentor, who I still work with and I maintain my research affiliation at ASU. We work with a Dr. Stephanie something, who's like the godmother of glyphosate research. And she's at MIT, and we have a study looking at glyphosate extracts on cells in a cellular study, specifically lung cells. And we're writing up those results now. And we do measure glyphosate, not itself, but the effects it has, the known cellular effects. And we can match that to sort of things like peripheral metabolic effects, as well as self-report exposures via our survey. And so we do measure that, and it's contained in our environmental toxin exposure index. So the effects that we monitor from glyphosate that are inferred to be from glyphosate are truncated and reported in the environmental toxin exposure index. And we can tease that apart even further, because glyphosate is one of the many systemic pollutants that are in our food, in our ground supply, in our water supply, and even my own research in BPAs, specifically TBBPA, which I've talked with you about regarding it's a flame retardant that's in everything from your clothes to this desk. And when we published this earlier this year in environmental toxicology, we showed that it had a very characteristic arrest of the TCA cycle. When we tagged these TBA45 cells with C13, isotopically labeled carbon, and we tracked its flow in cellular processes, we saw a complete arrest of the TCA cycle. And so we are actively involved in this kind of research, and this is what we do. And yes, we can look at. Please share the link for the environmental toxicology article. Micah, could you actually just put me and Alex's Google Scholar profiles into the chat? I think for people who are physicians and are attending this, and they're obviously equipped to read the research articles themselves and what we're working on, I think our Google Scholar profiles might be probably.
How many active publishings do you have?
Our science team has a total of 140 pubs, and they're in good journals. We're research one level scientists, and so we are publishing in very
publishing is what you do.
It's what we do. It's what we do. It's what we love to do. And so our total science team has about 140 publications under its belt, and we're currently, like I said, we're publishing in really advanced and prestigious university journals. And so hard to get these good journals. There's been a ton of corruption. Thank you so much. Yeah. Oh my gosh. Don't get us started on the corruption. That could be its own webinar. That is something that we are consistently reeling against, is this predatory journal and the fact that a lot of these science companies that are in the personalized, bespoke health testing space, their articles are like preprints that they've put onto a server, and it's not peer reviewed, and it's a sort of like a white paper, and everything is, there's spelling errors in it and things like that. And so, there's a time and a place, but not in your publication.
Is it a pay to play issue, or is it?
It's pay to play
content?
No, there's predatory journals as well. Whereas, you pay the publication fee, you're published.
Published, baby.
Yeah. And so,
the whole point of scientific publication is to have it peer reviewed by your scientific peers.
Have someone rip it apart.
And if you're
guys, tell me this is not true.
Right. And if you're publishing, if it's just like what you were talking about, just a preprint, that's not being peer reviewed. Or if it's at a predatory journal, the quality of reviewers is just abysmal. So,
absolutely.
I mean, to be honest with you, Matt, if you wanted to go publish something right now, I could just show you, give you a 30-minute tutorial. You probably could.
It's terrible. It's terrible. But making sure that you're publishing in good portfolios and good.
So if I look at when I look at references of people saying, "Oh, we did this study and we banked off of all this data or all these studies that were done previously," are people actively saying, "Well, I'm not going to listen to this one because obviously it was BS"? Or when you build that stuff, how does that work?
Very rarely do people read a study and then go to the references and see, well, what was this built on?
What was it built on?
Yeah, and so if anyone has been paying attention to our references, they're all in great journals. Even the science that we curate as part of our database, we have certain criteria, such as like what impact factor we draw from, right? We do not take, there's this publishing group, MDPI, MDPI will publish basically almost anything. I mean, it has to have some
Nothing
sort of
against,
muster.
and then, yeah, nothing against them though.
Right. So, usually like these journals will have an impact factor of less
Right.
than 1, meaning that on average, an article published in that journal has a citation less than 1 a year. Our impact factors are regularly above 10. And so, we're quite proud of what we've done. And so if you want to go to, and people are saying, who funded the research? Absolutely. That's a big thing. And so we disclose all of our conflicts of interest, if we have any that's pertinent to the research trial. We try to always have as little conflict, financial or otherwise, as possible. But pure science is sort of on the chopping block as of late in the last 50 years, even. Yeah.
Another question from Francis here. Do we need to stop supplements before the test, or walnuts, protein, supplements, probiotics? So Francis, just so you know, the test does come with instructions on what to do. Typically people are doing it in a fasted state first thing in the morning. So that's assuming you haven't eaten for 8 hours or so. And doing that will be ample for this test. And
what we do
discontinue.
what we will do is we'll continue your supplementation, continue your medically prescribed prescriptions. You'll report that to us when you go to our HIPAA compliant online survey and fill out your information. You'll report that to us, and that's all used to inform what's known as a bias score to correct your metabolite levels and really contextualize their meaning. So continue as is. We see a lot of issues with over supplementation. So we may come back to you and say, well, you're over supplementing, cut this back and do this a little bit differently, but
save you some money.
Yeah.
Are you stool testing yet? Testing and recommendations is the same as last one. So the microbiome test will be coming out in June, and Dr. Mohr there is actually the one that's developed it. So do you want to touch on that real quick?
Sure. I think we want to approach the microbiome test in a similar fashion that we did with the Aristotle, in that it's very easy to collect a sample. I mean, what we do on the sequencing side and the bioinformatics side, a lot of people are just not going to simply understand that. But when they're interfacing with the sample type, it can get icky, to put it kind of grotesquely, particularly when you start talking about how a lot of the products on the market literally make you have a little spoon and a catch. It's just not pleasant. So we've actually come up with a very innovative approach. It's very non-invasive. I mean, you do have to interface with a little bit, in that it's a little bit of a wiping action, but we're actually able to collect your adequate volume of sample. It's stable at room temperature for 2 months. You send it back to us, and we're actually able to deeply sequence that sample down to the strain level. So if you think about kind of the tree of life phylogeny, that's kind of like the deepest level that you can possibly get at profiling the microbes, understanding their function and how they're interacting with your health. So this is in terms of system biology and understanding what the metabolome means to your health. This is understanding what that symbiosis or dysbiosis potentially means with the microbes residing in your gastrointestinal tract. We all have it, by the way. I mean, literally, it's hefty. I mean, you could actually hold it in the cup of both of your hands. I mean, that's microbial biomass. So they're not just sitting there doing
living animals, not
well, I wouldn't call them animals. They're microbes, right?
Living microbes.
Yeah. So
living material.
Yeah, this is living material, and we're not just talking about bacteria. We're talking about viruses. We're talking about fungi. We're talking about single cell organisms, potentially parasites. This is a extremely diverse environment. In fact, it's the most diverse environment on planet Earth, residing in our own guts.
Yeah.
So understanding
biodiversity in there is unlike anything.
Yeah, it's understanding what is going on there is, I think, fundamental as we move forward with personalized medicine.
I've seen a lot of people talk about parasites. So from the test, you'll be able to derive whether or not someone has a parasite?
To an extent. Obviously, there are large parasites, which, we're not currently doing any culturing techniques, but we can get, we're working on getting actually basically a metabolic signature of their presence. Now, if you have gross, large parasites, normally that's pretty apparent.
That's pretty easy.
It's pretty easy.
Yeah. Usually don't need a test for that. And that's the difference. Usually you're getting, we return 6 times more species level information than your normal fecal test. And so that is a true vertical advancement in the resolution that we get from that sample. And that goes to everything that we do at Therium, you know, everything from the remote patient monitoring techniques like the non-invasive white, the dry blood spot sample, and the quality of data that we get. Your traditional health record, and we did this experiment this weekend, is about 15 kilobytes of data. When you take your traditional diagnostic tools and your results and you put them in a file, it's about 15 kilobytes of data. Every aerosol test on average, when we average them in our last batch, is 1.31 gigabytes of data, which is, you know, roughly 100,000 times more than the data that you're getting from your traditional diagnostics. So this type of large data with high resolution is really what you need to power these granular insights that we're able to glean.
On that subject of parasites, it's become kind of a increasing trend. I'm not sure exactly where it comes from, but as you guys have stated that, you know, sometimes people can have concern over parasites when they don't actually have parasites. So can you go into a little bit of possibly in your mind where this comes from, and then how could somebody know for certain if they have a parasite or not?
Well, to know that you have a parasite for certain, obviously you're going to have to do some type of diagnostics. I mean, we think of common parasites in terms of our own children. Like if you have children, you may have encountered things like worms. I mean, these
Your children are parasites. Yeah.
Right.
I thought that's what you were implying.
Well, I mean, so basic symptomology generally is how someone's going to detect it. I mean, again, not to get too vulgar, I mean, things like itching, things like that. It's interesting, though, that we have to understand in terms of like where we are in terms of history and even geography. Like if you live in the United States, you live in a very sterile, clean environment. Speaking openly, this is usually not a concern, okay? When you start looking at populations that live particularly around the equator, like in jungle type areas. In fact, I did some work that was looking at a tribe in the Amazon, and they had the highest parasitic load that we've ever seen in a fecal sample. They also had some of the lowest cholesterol levels ever recorded. Okay, heart disease was basically non-existent. We often think about, and I'm not suggesting.
I was just going to ask the question.
I'm not.
Are we going back to worms for weight loss?
I'm not suggesting this. I'm just simply I'm just trying to bring this up as an example. Everything, it's all context dependent. Now, I don't think I want to live like these people.
Right.
They don't die from heart disease, but you know, they die from other really horrible things, right? I'm just bringing this up as an example. There was actually interaction going on with your immune system, because if you look at the gastrointestinal tract, about 70% of all basically lymph immune associated tissues surrounding that tube, basically. So it's vitally connected with your immune system. These parasites were actually giving off little molecules that were interacting with the epithelium, the gastrointestinal lining, and then the immune system, and actually spurring cytokine cascades that actually had an overall protective effect, a hormetic effect.
These are inflammatory molecules.
Right. And this was actually causing a hormetic effect in terms of the liver and then cholesterol synthesis. So, you know, parasites, I'm not saying that that's probably it's a terrible example. I don't know why I just brought it up, but parasites, you know, first of all,
even having something as bad as a parasite, you can, in the context, see positive things.
Yeah, and deal with it, right?
Yeah.
These people have been dealing with it for a long time. I think a lot of it might be a little bit overblown. I think the issue comes into what's happening currently, where we're losing a lot of biodiversity and the gut microbiome in the West. And now the question becomes, well, what is taking up the place of those potentially beneficial microbes? That's where we start seeing shifts to more disease associated, particularly in terms of like diverticulitis, diverticulosis, colitis, Crohn's disease. Things that are increasing in our society currently are all tied to a lot of these basically, I would term them disease-associated microbes. It's not just the microbes themselves, it's what they're producing, their metabolites, and how that's interacting with our tissue. Now, if we're losing a lot of biodiversity, perhaps if you do get, you know, some parasites, they might be able to take up residence a little bit more easily. And then that's where things can be problematic, but that's it really doesn't occur very often here in the West. It really doesn't.
How do you lose biodiversity in your intestinal tract?
In many ways.
So I'll actually bring this back to nutrition.
Well, let me ask that in another way. You said me and Caitlin had really, really high biodiversity. How did we, like, because that's in comparison to other people, I would assume, in similar age and all that. How did we acquire something like that? Because it's kind of assuming that most people don't have good biodiversity in the United States.
Well, I'll ask this question. I hate to get a little personal, Micah. Were you born cesarean or were you born vaginally?
Vaginally.
Okay. So that actually,
is that on topic or just a question?
No, it's on topic. It determines early microbiome.
So yeah, exactly. It was once thought.
Thanks, Micah. Take us off the rail.
Okay, so it was once thought that you basically had a sterile microbiome, meaning there was no microbes inhabiting your gastrointestinal tract until you were born. Actually, that's been challenged now. There does appear to be some transfer that's actually occurring in the fetus, but the main inoculating event occurs when you're born. Okay, you're actually, again, discussion does get a little, vulgar for some, but you're coming into contact with those vaginal microbes, and they are actually the seeding elements that help form the initial microbiome, which is absolutely critical to not just your health for your digestion, but also building your nascent immune system. First couple of years of life are the most important for forming your immune system and how you're ultimately going to live throughout life. I mean, your immune system is not only tied to diseases that we think of traditionally, like various cold and flu, but also even risk of heart disease, cholesterol, lipid metabolism. It's innately tied with our overall.
So if I got a room of 10 OBs in the room and I asked them how important vaginal delivery versus cesarean delivery in the diverse microbiome, do you think they would give?
They know, yeah, they know.
So
in fact,
breastfeeding too. I mean,
well, so now what they're doing, they didn't used to do this. They're actually taking inoculum from the mother and putting it on the newborn baby. This is common practice now because we've understood how important this is. Now, I think Micah's a little bit younger than me, and luckily I was born vaginally, but some of my siblings were not.
I'm a C-section baby.
Yeah. They were not inoculated.
Does it?
when that inoculation was not happening. But now we know that is so vitally important. So, Micah, that could play into your results. Also, you live in a very small town. You're outside a lot. You're getting a lot of biodiversity. You're also picking up microbes throughout your life that can, compete basically with the other microbes in that environment. You actually, in some ways, want a competitive environment, right? Because if you're thinking about just very simplistic things like survival of the fittest, I don't want something that, not only is low in biodiversity, but it's not being challenged. So we don't have the survival of what would be a more beneficial microbe, a more robust microbe inhabiting our system. And also fundamental to the conversation of nutrition, eating a diverse diet. Eating a monotonous diet is not good for the biodiversity of your microbiome. And Micah, I know your diet isn't always the best because you travel a lot, but you are getting in a lot of different food stuff. I saw you eat the last time we were together, and it was pretty diverse. I wouldn't say it was good, but it was very diverse.
Incredibly diverse.
A lot of it was good. I did get an egg salad sandwich, which they gave me a lot of problem over.
From
But
7-Eleven.
From 7-Eleven, you couldn't find a food source.
yeah, we were in Texas and when in Rome. Anyway, a couple more questions here and then we'll wrap it up. Whoever is Zoom user that is commenting here and you're asking about getting on the practitioner program, please just provide your email or email me, micah@therio.me. I'll put it in here and we'll set something up and walk through it with you. We have a number of practitioners and companies that are bringing the test on. And then Becky asked, are the follow-up tests 3 months later discounted? So the Black Friday discount applies to tests right now. So if you do get on a subscription program, it will give you that additional 25% off the product. However, that won't apply in 90 days from now because it's just not enough for us to be able to feed all the mouths that we have to feed. So we have to, run lights, have a laboratory and all that stuff. So unfortunately, we can't just discount it to that point all the time. But it looks like that's well, one more question here. How do we store the data?
How do we store the data? Really interesting question. Obviously, we have to maintain HIPAA compliance and European GPDR standards. And so we actually do everything completely offline. The computer that is used to control the mass spectrometer, the gas chromatography columns, and the processes of what it does and when it does it, that is completely offline. That's actually by grant mandate. So that this is a research laboratory that is also used sometimes for research projects, federally funded research projects. And so with those federal dollars comes the mandate that this computer has to be offline. When we transfer it for analysis, we transfer it on a hard drive. That data gets stored on a laptop locally, and all the analyses are done offline. So your raw data never makes it to any computer with an internet connection. After we're done with that data, the raw data is put into cold storage, and then your results and the meanings of that data, the values of the metabolites are communicated via a simple Google Drive link in your inbox when your results are ready. And so that is end-to-end encryption, and only our science account and the customer has access or viewing privileges to that data.
Yeah. So basically, we have a very secure method for making sure the data stays intact. And as he said, all the raw data, like the stuff that is valuable, which is, all these values and these different things, that's totally offline. So there's not even a way that somebody can hack that. Becky did ask here, does testing recommendations include the type of exercise?
Absolutely. Exercise is a major part of our recommendations, and we see it come up in the most relevant domains such as cardiovascular health, where we may ask an individual to increase, their ratio of strength training. We may recommend very specific HIIT exercises, high intensity interval training, for mitochondrial biogenesis, which is one of the best things you can do to increase the size and function of your mitochondria. We may recommend increased aerobic activities, specifically in patients where we see heavy metal toxicity, and we're asking them to increase aerobic activities to essentially facilitate or synergize with other therapies to chelate and remove heavy metals from a person's system. So absolutely, exercise is a main constituent of our recommendations. In fact, the Institute of Medicine just wrote a position paper where they would like to start viewing physical inactivity as its own diagnosis. And so we're fast approaching the widespread realization of how important this is. And by all means, it is an integral part of our recommendations.
Kind of come full circle, don't we? It's like eat locally sourced foods, eat vegetables, proteins. This industrialization is really just, man, it's had so much upside in terms of production, but a lot of downside in terms of health.
Absolutely. Yeah.
Yeah, I was going to say one more comment. I think, sometimes people also kind of lose sight on the biggest levers of change and like actually moving the needle in some of these, health metrics. And it's hard for some people sometimes to hear simplistic answers or simplistic recommendations like, hey, your diet, the profile, the macronutrient profile is spot on. You're just eating 500 calories too much. Like sometimes people don't want to hear about it. Or like Dr. Jazzy was saying, like they come into, or a consultation saying like, well, look, I know that I've been eating good. I've been doing everything right. Why is my test showing this? Well, maybe you're not. And sometimes not everyone wants to hear that, but what we're able to do with the profiling, the granularity we're actually able to get down, again, going back to like what's actually going to move the needle. When people follow our recommendations, I don't think anyone they've had nothing but good things to say about it.
Well, we have had some pushback.
Well, I'm saying when they follow the recommendations.
One instance. So we have like a 99.9 something % success rate. We've had some pushback, but our protocols are designed using, leveraging the most advanced and well-curated scientific knowledge and modeled to your metabolic profile. This is the advancement of science. When as even if you never hear from us again, slowly you will see multi-omic testing incorporated in your doctor's office. You will see, as digital twinning becomes more widely adopted and more accessible to physicians, right? Digital twinning right now is a bunch of code on our computers. How do you take that to, a real, user interface that physicians can use, and that doesn't take up a lot of time, doesn't require a high level of bioinformatics skill? You will see multiomics and digital twinning being the forefront of your traditional doctor's office. This is medicine 3.0. This is where it's going.
Who's the real world leader there right now?
Institutes. So various institutes. You have people from the Zuckerberg and Chan School of Medicine. There's a few researchers in there. You have people like Rob Knight. You've got a lot of great people at the Institute of Systems Biology. And us, I would say, we're really, moving the needle and pushing the envelope on how we combine patients' data with recommendations, and that's what our current work is in. This guy here is about to get a very prestigious T32 postdoctoral award to. It's a postdoctoral award. It's a type of NIH grant. Yeah, so he'll get that to start even learning and contributing more to artificial intelligence and digital twinning.
Yeah. Well, great. Just so everybody knows that's still on the call, we do have Black Friday, which is starting now. And that Black Friday deal is 25% off all products store-wide. So if you go to therio.me, you can get a 25% discount on the products. It takes about 2 to 3 weeks to get your results back. So once you send it to our laboratory, you can expect about 2 weeks to get your full report. That'll include the 12 key health domains. So what we talked about today was just the nutritional index. And as you can see, there's a lot that goes into it. So they really do quite a depth of analysis that's unprecedented. And as he said, 126 metabolite values, while that doesn't sound like much, there's no human brain that can compute the modeling that is required, because it gets exponential, because now you have to you essentially have to draw the relationships between all those metabolite values, and they do that. In addition to that, it has the disease signature list, which will identify, hey, what are some things that disease signatures that your body, sorry, I'm trying to say this in a compliant way. But anyway, it can essentially identify issues in your body at a very, very early stage, which can be really helpful for monitoring. Or if you have family history of things, that can be massively helpful, because if you find things early, the outcomes improve drastically. And the third thing, it has the personalized protocols with what they said about the digital twinning. It's basically running these simulations, thousands of simulations, to find the best mix of things that's going to get you the fastest results. So that'll include supplementation, diet, exercise, even drugs at times, and interventions if needed. So it'll include all of those things. And if you go to therio.me, I'll put it in the chat here, everything is 25% off right now. So I appreciate everybody jumping on today.